So good evening everybody, it's from Jayashree. I am going to take this operational amplifiers. The topic name is current to voltage converter. So the current to voltage converter under this topic is analog and digital ICs. Okay. This is what this current to voltage converter. Here the input signal is applied to this. This is what this current to voltage converter circuits. Assuming this ideal op-amp circuit, and since AB is equal to 0, V1, V2 is initially 0. Okay, IB1 is equal to IB2, that is equal to 0. Okay, so let us see the circuits. The current to voltage converter is also known as trans impedance amplifier. Is a circuit configuration using an op-amp that converts the input current signal into the proportional output voltage. How it works? Okay, let us see how it works. Input current. The input current signal is applied to this inverting input terminal of an op-amp. This input current can be generated by the sensors, photodiodes, or any other current producing device. Next one is what? Feedback resistance. The op-amp is configured with the feedback resistor connected between its output and the inverting input terminal. Next one is what? Output voltage. The output voltage of an op-amp is proportional to the input current and is determined by the Ohm's law. V is equal to IR, where V is the output voltage, I is the input current, and R is the feedback resistor value. Next, applications. So applications include photo detection and sensor interfacing and optical communication. So trans impedance amplifier are extensively used in photo detection system to convert the small current generated by the photo detector in response to the incident light into the voltage signal. This voltage signal can then be amplified and further processed. Many sensors. Next one, sensor interfacing. The second application is what? Sensor interfacing. Many sensors, especially those that produce current signals as their output, requires the current to voltage converter to interface with the downstream electronics. The trans impedance amplifier allows these sensors to be directly connected to the voltage biased circuit, voltage based circuits. Next one is your optical communication. In optical communication systems, trans impedance amplifier convert the tiny current variations in optical signals received by the photodetectors into the voltage signals. These voltage signals are then amplified and processed to recover the transmitted information. Okay, this is what these applications of this circuits: photo detection, sensor interfacing, and optical communication. Next one is what? Biomedical instrumentation. In biomedical application, trans impedance amplifier can be used to measure currents generated by the biological cells or tissues, such as in patch clamp experiments or electropsychological recordings. Next one is what? Signal conditioning. In signal processing application, trans impedance amplifier are often used for conditioning and pre-processing signals before further amplification or processing stage. They can provide an impedance matching and convert current signal into voltage signal suitable for subsequent circuitry. Signal conditioning. That is, in signal processing application, the trans impedance are used for conditioning and pre-processing signals. Okay. At last, the application is what? Feedback control system. The trans impedance amplifier can be used in feedback control system where the input current represents a control parameter. By converting this current into a voltage signal, it becomes easier to implement control algorithms and feedback loops. Okay, so I will repeat the applications. Number one application is photo detection. Number two is what? Sensor interfacing. Number three is what? Optical communication. Number four is what? Biomedical instrumentation. Number five is what? Signal conditioning. Number six is what? feedback control systems. These are the applications of current to voltage converter. This will convert current into voltage to the maximum level. So thank you all.